So, let's look here. All the grades have been updated. If you have anything late, turn that in by Sunday. If you haven't yet turned anything in, as far as quizzes or anything you don't have done. So let's scroll down here to week 9. We're covering NOSes this week in week 9. And then next week, research night. And you don't, no class that night, but you're going to devote the whole night to get your start anyway on your research paper. Week 11, we're going to have a gentleman from Entree come to talk to us briefly about remote software. And he's going to be using Dester or Remote In to talk about remote software, which I thought was kind of cool. And so he's going to be talking for about 15 or 20 minutes about software that they use, VPN software, Citrix. I told him we've used TeamViewer. By that time, we'll be using VNC as well. And I read your guys' responses on the TeamViewer lab, which seemed pretty positive. Some of you, most of you said you're going to continue to use it in some form or fashion. And so he's going to be remoting in on week 11. If he can't make week 11, he'll do 12, but he said he'd more likely can do week 11. So let's jump right into week 9. And again, I just posted or opened up the quiz, made it active today. And it's over some reading on subnetting. Subnetting is your take-home exercise tonight that you'll be doing after our discussion on NOSes. So the reading subnet in week 10, I put the due date March 21st, which I believe is next Monday. So it's due Monday night at 11:59 versus Sunday night at 11:59. So that's the reading. I'll click on to show you what the site looks like. It's 8 steps to subnetting, understanding subnetting. And then there's the 5-question quiz is based upon those 8 steps, basically. So if you do the reading on the subnetting, you should be good to go for the quiz questions. There is one essay question in the quiz. The rest are multiple choice. Start on that page. So go back. You guys, are you connected to the internet? The internet dial-ins?
I can't, the link doesn't work.
Yeah, I think it's just on my connection here. I'm on Wi-Fi, so probably just my connection. Like that flashing.
Highlight it and then right click and then open.
Yeah, just click on it. It should open up in your browser. So week 9 reading is on subnetting. There's 8 steps you'll have to read. I'm not going to try to click on it because my Wi-Fi is not working too well here. Then week 9 is on 5 questions on the reading. There is one essay. And the Networks Call Lab, go ahead and click on that. It's going to be due in week 12. And the Networks Call Lab is where you're going to get a list of about 20 businesses around the Rockford region. And what I want you to do is you're going to ask a list of questions for these 20 businesses. And so here's the questions. It's like a script that you'll use. Hello, my name is Chuck Conkle, network student from Rock Valley College. What's your name? Now, again, this is a person just answering the phone on the other end. More like could be a front desk person, could be the CEO of the company, depending on the company you call. And say the person says their name's Tim. Tim, I've been asked to call, and this is a key part, 5 top businesses. 5 top businesses, and ask the makeup of your network environment. Now, even though you have 20 numbers,
I still can't connect to this.
do what now?
I'm still not being able to connect.
Can you look off his? Is he connected?
Oh,
Or you can look up here too. But the key part, even though you have 20 numbers, you're telling the user top 5 businesses to kind of puff them up a little bit, that they're pretty awesome. Because you're buttering up for the hook here in a second. It says this is supposed to help me understand how networks are used by, again, top businesses in a real world setting. Could I ask you 7 questions? And then I put in there pause.
this one.
Because anybody work in sales and retail ever going through?
I've been in retail for 20 years.
Okay. The pause is critical then, right? I worked in retail going through school, and that's the uneasy part of a sale, but it's the critical part of a sale. If you don't pause, you lose the sale because you're rude to a person and they're like, okay, can I think for a second, right? And so you're pausing, waiting for them to respond, and if you hear them go like that, that isn't a response, and you can say, hey, would it be okay if I just emailed you the questions? But don't say it immediately. I don't want you to call them and go, my name's Chuck from Rock Valley College, I've been called to call top 5 businesses. Could I just email you the questions? Don't do that. Okay? See if they'll take the time, which some of them will, to answer your questions, but most of them probably are busy and don't want to. But they don't want to say no to a student. They just said their business is a top 5 business. And so you'll pause. If they say yes, say thank you for your time, and I will make it very quick. If they say no, thank them. Even if you offer the email option after the uneasy pause and they say, like that, you say, can I email you? No, I'm not interested. Okay, thanks for your time. Appreciate it. Have a great day. Then go on to the next number. So out of the 20 numbers, in my experience, you'll probably get 1 or 2 that'll say yes, either to email or answering your questions. And that's pretty good, actually, getting 1 or 2 to answer your questions or say yes to email. And so if you only get 2 responses out of this 20 numbers, that's great, all right? And what I want you to do is you'll fill out this sheet on your computer as you're on the phone, or if you want to write it down, then fill it out later. But you're going to submit 1 sheet per response, okay? And so here's the questions you'll ask. Does your network use Ethernet, token ring, or both? If they say, I don't know, go on to the next question. Number 2, what's the transmission speed of your network? Again, they could tell you gigabit. They could say, gigabit, we're getting ready to upgrade to a faster network, but we're not there yet. Whatever their answer is, just write it down. And then what type of backbone does your network rely upon? This could be Cat5, this could be fiber, this could be both, this could be, on a grander scale, it could be, connected to a, T1, T3 possibly, with Cat5 and backbone of fiber, all 3. But whatever it is they tell you, jot it down. And then what type of wiring does your network use? Is it the same as the backbone on your workstation, to your workstation? So again, they could say yeah, or they could say no. Network uses fiber, and our backbone is Cat5. They could say that. That's an example. Does your company use WAN technologies? And remember, that's technologies that's connected to outside of the building to an internet connection to do something to another business, connect to some other business, some other entity within their company. If they have salespeople, a lot of times they'll have a WAN connection for folks to connect in a VPN, things of that nature. And then what topologies is in each location arranged in? Remember, star, ring, hybrid are the topologies we went over, that bus topology as well. And so all of these topologies, they could say, or they could say, I don't know. It just works. Okay, whatever they say. If money was no object, what type of upgrades would you make to your network? If you only had enough money for one of those upgrades, what would it be? And so again, you'll just get the responses. I don't have the company name on the sheet, but if you could write that in somewhere, that'd be great. And and we'll put this together on a spreadsheet and get to see a layout of everybody's responses. And again, you have till week 12, we're in week 9, so you literally have 3 weeks to finish this. Get a list of 20 numbers, and 20 numbers could be Rock Valley College, it could be hospitals, Pepsi, Coke, insurance companies, restaurants, just a plethora of different companies that you can call. I will tell you a couple companies that get called every semester because I promote it, be Rock Valley College for sure, Rockford College, Rasmussen is great. Let's see what else. Pepsi here in town, Coke here in town is good. Stenstrom Construction is awesome. Responders. Trying to give you a couple more that would be good responses for you. Let's see. What is it?
The school districts,
What was it?
the school districts, like Rockford.
Yeah, Rockford School District might be a good one as well. I have students call them all the time, but they're one that students call for sure. Woodward, good connection. They're, we're called Woodward Technology Center, so they're pretty responsive for the most part. But, that's just a few that I'm off the top of my head that students do call every semester. So more than likely, I might get somebody that's answered these questions before. Now, let me just stop there for a second while we're talking about answering questions. In IT, you might know if you've been in, some of you are in IT and you've been in IT for a while, or people that are. It can be frustrating, and sometimes people in IT might not be the most positive people you've ever talked to before. And so they might be a little negative, possibly.
They're not in the sales department.
Right, well, yeah, exactly. Yeah. Yeah, what'd you need,
I
man?
forgot my laptop bag.
Oh, yeah, I was wondering who that was.
Sorry.
Jim Conley, everybody.
Hey, gang. See ya.
Thanks, Jim.
Thanks, Chuck.
Yeah, and so they might not be as friendly as you want to be. In fact, I had one student last semester say the person on the other end said, "Get out. Don't even think about it. Do not even think about going to the networking. You're going to get dumped on. It's a peon job. You're not going to be liked. You're not going to make any money. I've been passed up for 5 promotions," the guy said. It's not going to happen. So just whatever hopes are telling you, forget it. That was one of them. But I've had also students get jobs during this little adventure assignment. They've actually said, "Hey, we're looking for an intern, or we're looking for somebody to, do some stuff. Are you interested?" I've had students actually get leads on jobs on this. So, you get 2 spectrums, wide spectrum of real negative to, pretty positive for you. So regardless of what the feedback is, just, again, be as positive as you can be. Don't cry. Try not to. don't get upset and yell at them. Just, let them vent a little bit. But because that could happen, just so you know, just a disclaimer, that could happen. I've had students have that happen to them. So questions on this is actually found in week 9. This template is, yes.
Are you gonna give us the list of 20 companies? Or
No, you
want us to
make them up. Yeah, you make up whatever one you want.
So do
I just gave you a few examples of some that students have called over the years. And the ones I gave you, by the way, respond fairly well. But then there's tons of other ones out there, which once you go, in the phone book or wherever, nobody uses phone book anymore, go online. Or people a lot of times is a good lead. People your parents work for, or your, brothers, sisters, friends, associates, whatever. Those are good leads I would start with, along with the ones I mentioned. But you can come up with a list of 20 pretty quick.
So do you wanna see the list of 20?
I don't, no.
You're looking
Do not.
for a minimum of 2,
1 to 2.
2 of these.
I mean, it's average. Average is usually 1 or 2. If you only get 1, you only get 1. But if you start out with 20 numbers, the average students generally get a feedback for either verbal on the phone or email is generally 1 or 2.
So if my first 2 happen to talk to me, then
Done.
Right,
Got it.
and that's about 10, so we say.
Do what now?
"Oh, Can I have 10 minutes of your time?" Is it about 10 minutes?
Yeah, I would say 10 minutes, depending on how fast you talk. Yeah, 10 minutes would be a good estimate.
Depending on how much they want to get to.
Yeah, how much you want to get. Yeah, you generally don't want to put a time limit on it. Just say it won't take that much time. I'll go through it, like I say on the front of the script, that I will thank you. If they say yes, thank you for your time, I will make it very quick. And so you're just not giving a time frame, because if you say 10 minutes, they could say 10 minutes up. You're only 5 minutes, five questions in or 2 questions in or something. So.
Yeah, you could say, right, maybe.
So just very quick, I'll make it as quick as I can. and as painless as I can. And use your personality, you have a script here, but, use your personality for sure and your discretion and all that. So, so this is your script. Again, one per company that does give you feedback. And like you mentioned, if you get 2 feedback immediately, you're done. So all I really like to have is, if I got 2 per student, that'd be awesome. Again, that's average, or sometimes students call 20 numbers and literally only get 1 feedback. So, if you get 2 right in a row, that's awesome. So, questions on that? All right, cool. So let's go back to the week 9. Okay. Then go into the 10 lab, if you wouldn't, even though it's week 9, remember I had to move, week 10 was week 9, week 9 was week 10. We switched it. So we didn't want you to be on the night off, the night after, the week after spring break. So this one's a subnet exercise. It's a take home. And basically there's on the subnet exercise we'll look at in a second, gives you the example of each one first done for you. Kind of helps you out on how it should be done. You'll download it, complete it, and what I'm gonna have you do is hand it in, not next week, but when we're here next, which is 2 weeks from tonight, is when you'll hand this one in, all right? So let's go ahead and look at that exercise real quick. I'll show you what it is. And you can use a scientific calculator on this exercise. And you'll be using on a calculator, the scientific calculator, you'll be using the bin and the DEC buttons, decimal and binary buttons too, is what you'll be using if you've never used a scientific calculator. They're available for both your Windows devices, Mac, and even your phones have a scientific calculator, base calculator on your phone. So here's the exercise. The first exercise on the subnet is you're going to take the first number in the IP address to identify the default class and associate the subnet for the address. Now we'll look at page 2 in a second to show you what the classes are. Number 2, you'll calculate the network ID using the numeric values in the IP address that correspond to 255 in the subnet mask, then fill in the remainder with zeros. 3, you'll calculate the host ID but with the numeric values in the IP address that correspond to the network mask. So let's go to the page 2 and I'll show you. You'll need page 2 to help you with page 1. Page 2 shows you the classes you'll need to know. So if in an IP address, it has in an IP address 4 octets, okay? And the octet determining the class is the first octet of the IP address, okay? And so that's what this graph's referring to. So if in the first octet, the IP address is in the range of 1 to 126, it's a class A, which is a local class for local networks. If it's 128 to 191, it's class B, and we'll talk about why 127 isn't there yet in a second. And then class C, 192 to 223, is a class C class for networking. Now, if you go to the second column, you'll notice it breaks them down into what the network ID portion of that class is. It would be W, which I'll write it up here to help you on that. W, X, Y, Z is what they use instead of 1, 2, 3, 4. So the network ID portion, W, would be what's used for the network ID, so it would be the first octet. So in this case, if say the network ID was 110, that would be the 110 dot something, that 110 would be the network ID portion. The host ID is the rest of the octets, the other 3 octets, W, Y, and Z octet. The available networks on this is 126, the host per network, 16 million hosts per network. Class C, same thing, except for you'll notice on the network ID portion, it's the first 2 octets, W and X. The host ID portion is the last 2 octets, Y and Z. Available for this is 16,384. Host, 65,534. Class C, the network ID portion is WXY. Host, Z, And the available networks available on the Class C is over that 2 million number, close to 2,001,000 number. And then 254 hosts per network. So we'll go back to the first sheet in a second to clarify how that works. But let's talk about why is 127 not a part of the class octet logic? Remember? What's that 127 number for?
It's home.
It's the home, right? It's the local host. It's a loopback. The 127.0.0.1 or local host. And that's mentioned here on the second bullet point. The third bullet point talks about all bits within the network ID cannot be set to 1. All ones in the network ID are reserved for what's called an IP broadcast network. And then all bits of the network cannot be set to 0. This is reserved for routed networks and will not be routed, or local networks will not be routed. So the following addresses are non-routable, as it is in the white document. They're called the white documents. RFC 1918, these blocks of addresses can be used for private networks. That 10.0.0.0 through that 10.255.255.255, 172.16.0.0 through that 172 numbers, Class B, and the 192 through that 92 number. Now, in your home routers, well, you guys know your IP addresses maybe from your home routers. Looking at this chart, what class is your home routers in? Some of you. Anybody know? Is that one, as you have a 192 number or 172 number? What do you got? 192? 168.1.1?
Yeah.
Okay, so that's going to basically be a C. And a lot of times you'll see C classes used where the network's local, right, to the environment, and it's also connected to a WAN connection outside of that environment, which in a router's case, that's true because your ISP gives you your internet connection, which is a WAN connection coming into your house, and it can also talk now to a local to your house through that routable address, which is a 192, generally a 192.168.1.1 or 0.1 or 1.0, something like that is what you'll generally have for routers. I have seen routers though in a Class B as well, a 172 range as well that some of you might have at home. So if we go back to the first sheet, let's look at the first sheet. The first example is done for us. The 192.102.197.23. It's a Class B because the first octet's in 129 and it falls in a Class B class. The subnet, what you do for the subnet is basically because it's a B, you're going to take the network ID portion and that's going to become your logic for how many 255s are available in that class. All right, so in a Class A, you would have 255.0.0.0, Class B, 255.255.0.0, Class C, 255.255.255.0. Make sense? Class D, which there is one, by the way, we're not using it, but there is a Class D. All 4 octets would be filled up with a numeric value. Default will be 255. So Class B, the default subnet's 255.255.0.0. The network ID, because it's a Class B, uses a Y and the W and X. And so the first 2 octets are used for the network ID. So it's a 129.102.0.0. And then the host ID is going to be the last 2 octets, which is the 3 and 4 or the Y and Z. And it's the 197.23. So let's go to the second one. The second one is 131.107.21. What class is that in? That's B. So it's going to be B/, same subnet, right? What's the network ID?
131.107.
Gotcha. And the host? Somebody else? 2.1. There you go. Make sense? Now, there are some tricky one in here. I'm not going to go over which one it is. You might already have seen it. But it was mentioned in page 2, the tricky one. So just note that. If you see something like, oh, that's kind of weird, go to page 2. It'll help you out. And read the little notes on page 2 about subnet rules. Make sense? All right, so let's go to page 3 now. Page 3, we've done subnet, network ID, and IDs of the network, and how to break it apart to class. Now we're going to go into binary conversion, because when you're doing subnetting, you have to know binary, you have to use binary to determine the correct IP address ranges to create. And when you guys go through the little tutorial I have you read, it walks through step by step, really easy, how that's done. So the binary conversion exercise, you're going to take an IP address, convert it to binary, and then the first one is provided for us. So number one, you convert the first decimal binary to binary, or the first octet. The second octet, number two, to binary. The third octet to binary. The fourth octet to binary. Then you'll add leading zeros, because you have to have 8 bits per byte. So every one will need to be filled out with zeros on the binary IP column. Then you're going to separate the octets with decimal points. So let's look at the first example. And here's where you use your scientific calculator. You do a 122.131.2564. So if you take a scientific calculator and hit the bin number or the desk number, type in 122, and then hit the bin, it's going to give you that 1111010. And is that 8?
Yes, no,
7, right?
7.
Okay, so we're going to add a 0. You'll notice the answer on the right, on the binary IP, add 0 to complete the audit, add a 0 to the front of it. So the second one, 131, that's the binary for that one, and that is a full 8. Third decimal to binary is only 5, so add 3 to that one, 3 zeros to that one. And you'll notice as we're going along here, we're just separating the binaries by commas is all you're doing. And then the last one is 64, and 64 has 7 bits in it, and so you have to add a 0. And that's it. That's all you got to do. And so on my iPad, let me pause this real quick. Just gonna pause
On
that
the
way.
third,
So let's go to the next page, the last page. And this is where you're converting binary now to decimal. And so you're taking a binary number, 01110110, and then hitting the, you'll be hitting the bin to type that in, then hit the DEC button, and you'll get 118. And what you're doing on the first column here is just separating by commas. The third column, you're separating it or by periods is all you're doing for each one of the binary octets. Okay? Questions on that? So again, on your scientific calculator, you're just going to start the reverse of that. So somebody give me the first octet on the second line there. I'll type it in and show you. What is it? What's the first line on the first octet? Second line, first octet.
10101001.
1010.
1001.
And then I'm going to click on the des, and there's my decimal conversion of binary. Make sense? All right. And then you'll turn that in 2 weeks from tonight, that finished sheet of paper. And you do have reading on, more reading on your what subnetting is all about, more as far as how it's done as far as in the real world. It's a very introductory article I'm having you read, but it will help you. We do teach in Cisco in this, in our division, does offer subnetting, which I recommend students taking. But, you know, when I first learned subnetting, it was all done by hand. We didn't use calculators. And it's not real hard to do subnetting once you understand the logic behind it. You know, the nice thing about it is you're converting everything in binary versus what everybody's used to using in America, decimal, and you only have available to you zeros and ones. And it's a lot like 1 + 1 is what conversion is for, and also subnetting is all about. And so you'll find out more about that when you read the article. And so that's due 2 weeks from tonight, and then just turn it in. And so you won't forget, let's do this to kind of flag your memory. When you finish it at home, if you could go ahead and go into that lab for this week 9 and submit your name, that'll kind of let you know you've done it, you finished it, and let me know you've done it, and then I'll just collect the papers when you guys get back 2 weeks from tonight. Okay, tonight we're going to talk about the network's characteristics of different NOSes. We're going to do Windows NOS, Windows 2012 R2 is where we're at right now. It came out in started the beta test in 2012, but then its most recent release was 2014, and that's where we're at right now. And by the way, in week 13, you'll be creating clients' usernames in a Windows server, in a Mac environment, and then also in a Linux environment, those three. So some of these things we went over in the first few weeks as far as what a network operating system is. This whole presentation's on just network operating systems, some requirements. And then after we're done with this, we're done and you can do your take home at home. And the 20 calls, if you have questions about that, let me know before you leave. So based on the client server architecture is what a server is all about. And so it's different operating system than a client operating system that everybody here is used to using. The NOSes manage shared resources like files, users, computers, printers, things like that. And they're actually called in networking objects, what I just mentioned. Just objects of different types. There's some objects you can add to in networking, there's sub-objects you can't. And some of the terminologies in networking is called, like a tree, you have a root, you have branches, and you have leaves, right? Now, can you add to a root of something? A root. If something's a root, or let's go even more further, deeper than that, a seed. A seed, can it become something? A seed. When you plant it, yeah, it becomes something, right? And then a root branches up, whatever it is, we'll say a trunk of a tree. And from a trunk of a tree sprouts branches. Can you add to branches? And if you can, what are they? Can they add other branches? Can they add, yeah, they can add other branches. And from branches, what's at the very end of branches?
Leaf.
Leaves, right? And can you add to a leaf? No. And so leaves and networking would be like a printer. That would be a leaf. You can't add it to a leaf. All right. A object you can add to in networking would be, another leaf would be like a switch. That would be a leaf. All right. A file server, a leaf in and of itself. But like a group of users would be like a branch where you can add multiple users in a group of called marketing, we'll say, or sales. And it's represented, and we'll see a picture in a second, when you're setting up a network of a tree of all the different parts of your network and how it's designed. But the main thing about a network operating system is, first and foremost, is it shares resources, manages shared resources. It also has tons of other built-in customizations. And customizations are used for managing users, managing objects, devices, and various components that you can learn about in networking with the network operating system. So one of the items a network admin will have to do is figure out what the minimal requirements are for the network operating system that they're going to be installing. It could be Windows, it could be Linux, it could be Mac operating system. So determining every network operating system has what's called, and we'll see a slide tonight of a minimal requirement, right? Of this is how much memory is minimal, this is how much hard drive is minimal, things like that. Now that's not optimal, it's minimal, meaning to make this run, you've got to have at least this, right, for it to work. So when you see minimal hardware requirements, that's definitely not like optimal requirements, if that makes sense. And so that's something that we'll talk about. So questions you ask when you're thinking about an operating system, a network operating system, is what kind of applications will run on the server, how many clients are going to connect, how much storage space is each user going to need. I've seen companies give everything from 5 megs to a gig of space or unlimited space. You know, they just keep adding space to the network. and how much downtime is it going to take to add your network operating system and server, and then how much can a company afford. So determining the optimal server requirements determines answering those questions that we just went over, and what type of applications, how much memory. There are applications, by the way, that do run off server to push out to clients. Vendor requirements as well, like third-party packaged applications will have requirements as well. And then the server, to be reliable and not to spend as much time in some, or too much time on something, you need to realize that there could be, if something was to fail, how would it affect your company? Okay, and when you're designing it, how would it affect your company? What are some fail safes in there? And so also some other important NOS functions are efficient communication, resource sharing, and then support tasks for clients, like creating and managing clients you'll need to know, enabling clients to connect to the network, allowing clients to share resources, managing clients' access to shared resources, letting them in, letting them not in, giving them read-only, giving them write access, being able to let them share, not share, and then facilitating communication or training with those clients or employees is important. So one of the first things you do when you go to work is log in, right? And you log into generally a server, and it redirects you to a authentication piece, an Active Directory is what it's called, to authenticate you to the network. And your username and password is stored in there, and you can log in from any computer that's connected to that network. And since Windows XP days, we've changed some protocols with file access called the Common Internet File System. The older one was actually called Server Message Block. And basically what this allows us to do is support a lot of different types of authentication and file types where other OSs can talk now to your server. So here's an example of multiple clients getting up in the morning, going to work like you're going to do tomorrow morning. You log in, it goes to a redirector on the network, hits Active Directory on the server, and authenticates you or not, doesn't authenticate you, depending on whether you have the correct username and password. Middleware, you might have heard of that term. That has to do with request responses between client and server. And that would be middleware would be such as an email filter would be middleware. You could even say switches are middleware devices between client and server. Hubs would be middleware. Then there's a term called three-tier architecture, which is client-server architecture incorporated into middleware. So you have your client, middleware, server, technically. All right? Middleware is everything I just mentioned, pretty much. Right? You could include in there also Cisco phones, voice over IP phones could also be included in that as well. And so anything that helps communicate that network in that network architecture. So here we have multiple clients, whatever the middleware they're using to connect, and then the actual server. All right? And those middleware, like I just mentioned, could be switches, hubs, routers, and that type of nature. So users and groups, and we actually teach this here on campus as well in Active Directory. Our server class actually, Stephanie teaches on Active Directory. Actually, you can go out and buy a Bible. Literally looks like a Bible, really thick on Active Directory. And basically what it goes over is all the rules and regulations of Active Directory. What you can do, what you can't do. You can literally tighten up your network to the nth degree with Active Directory, because we could actually have this room split in two. This room over here be marketing, this be sales. When these guys log in marketing, you have certain rights and privileges that this group doesn't, and then vice versa. Also, I could say you guys can log in from 9 a.m. to 6 p.m. or 7 p.m. You can only log in from 8 a.m. to 5 p.m. or something. And those are the type of rules that you can bring down. You can even bring down rules of this group can only have access to Internet Explorer web browser, Excel, Microsoft, and Exchange email server. That's it. That's all you can get. Nothing else you can get to. You can't install applications. You can do all of that with Active Directory. That's how much rules you can add to rules on Active Directory. What's cool about Active Directory is a lot of people don't know is you can do what's called roaming profiles, where you can go anywhere in the network on any computer, and if you're in marketing or sales and you switch and go to somebody else's computer to log in with your credentials, it's going to suck down those roles to that computer, and you're only going to have the rights that were programmed in for you by the network admin. It's also nice when you get a new employee, you can create network profiles in Active Directory to just copy over marketing profile to this new employee. Boom, they've got everything they need just by adding them to that bucket profile. And because before the network operating system days, before we had that, we had just clients mainly, everything was done locally on the computer to be able to set rules. And now with Active Directory, you can do it globally on a managed server, which is a lot nicer. So when it mentions resources on a NOS, Active Directory will be one of those resources. Generally, an administrator account is used for only certain users in IT generally. They have privileged users to have unlimited rights to a server, domain, and all the objects. You do need at least one admin on a network to be able to set up all the rules, at least one. You don't want to dole out your network administrator or your administrator account to too many people. There are some businesses though that do that. They do like have a lot of people, probably too many people as an administrator, which can kind of be scary. Yeah.
You can, I took a course years ago about that, but when you get into a root system on Linux, really be careful. Don't start deleting anything because you can really screw up everything.
Oh yeah, for everybody. Yes.
Everybody,
Yeah.
When we first started teaching us the logic pass.
Yep, and same in Windows too. You can do the same in Windows environment. If the admin account should be very limited. Now, admin account is different than admin rights. Okay, there's different creatures here because a lot of people need admin rights on their local computer to do a lot of functions for some of these softwares today. But that doesn't mean they have admin rights to the network. Okay, because you're probably familiar with admin rights on your local client. That's not what I'm talking about. I'm talking about administrative rights on the network to make far-reaching changes on your network server, operating system, to user accounts, to Active Directory, and such. And so administrator accounts also one of the key users and groups. Usernames is another one. So multiple usernames, like say we have a bucket for marketing, a bucket for sales, and we add in those shared resources for those two groups. And groups are based upon what resources they need. So I can add to those buckets of marketing and sales printers that they need, where everybody has access to those printers. I don't have to go into every individual user and add them. I just add them to a bucket for marketing, a bucket for sales, and Active Directory, and they now have access to all the resources, printers, folders, applications, data that they need. So here's an example of users and groups. We've got a user groups called teachers, students, administrators, right? You'll notice in the teachers, they can write, read and modify rights to programs, full control to grades, and no access to staff. Students can read programs and access them, no access to grades, no access to staff. Administrators don't need access to programs, but they do need read and modify to grades and full control to the staff in total. And staff meaning the entire bucket of groups of users, which would be teachers, students, and administrators. So one of the things in users and groups is you set up that hierarchy in your network before you ever do anything on a whiteboard, generally on a Visio chart or something. And it's in a hierarchical group of who's going to be where, what buckets do we need to create, and buckets or groups for that network. And you arrange them, and you begin to add in on a whiteboard or on a Visio chart what permissions these people need or these groups need. And then after that, you can then go into your network operating system and begin adding those changes, restrictions. So modern network operating systems organize data by these following objects I talked about at the first of class. Users printers, servers, data files, applications. All network operating systems have what's called a network directory that organizes these resources by categories. And an example would be a file system directory, right? Would be an example of a category in a directory. Users would be a category in a directory. Servers would be a category in a directory. Printers could be a category in a directory. Make sense? Applications could be that category in a directory. So one of the key pieces in authentication on the network, though, is called LDAP. It stands for Lightweight Directory Access Protocol. It is an open source protocol that works on both Windows, Unix, Linux environments across the board. It's even used on a lot of web servers for authentication as well. Like here on campus, when you log in to your Eagle account, all right, that same username, LDAP authentication, is used for online services. It's also used, LDAP is used to log into your RVC email on Google. But you'll notice you have Google, online services, RVC Eagle, all three separate entities, separate altogether. But LDAP is used here on campus locally for authentication. Does that make sense? So you might have wondered whenever you've logged into any of those services and then you accessed another service immediately, you're like, whoa, I didn't have to log in. Why is that? Because you're on that same browser, number one. You've already been authenticated through LDAP, number two, and it sees that in your browser and lets you into that source. Make sense? Now, one of the other features on LDAP is, besides authentication, is LDAP is referred to only things like person on a network. And so, can devices authenticate? Yes, they can. Definitely authenticate. Good question. Good question. I just thought of that. So, can devices authenticate? Yes, they can. You guys are very talkative tonight. Anyway, so give me an example of devices that can authenticate. What do you think of devices that authenticate? I just thought of something. What was it?
Yeah, your phone.
There you go, phone. Yeah, swipe, you have to give a pin or something. What else? Laptop, good. What are some other devices you use every day maybe to authenticate? Some types, they car keys, right? Yeah, I don't have one of those, but yeah, they have some nice cars that do that now. In fact, I rented one last time I went back to Missouri. I think it was a proximity key where push button. It's push button start. You went in and you didn't have to unlock the car. As you got close to the car door, it was unlocked and then you could get in. And I thought that was kind of cool. So yeah, authentication is used on a lot of different devices. And LDAP, though, can be used even on devices. Even though it's not mentioned on the slide, it could be used to connect to door access, as an example. Using LDAP to connect to a door for users, using a proximity card, which I use to get into these doors. The way these doors work here is when you need access, you get it hired here, you need access to a door, you have to put in a ticket. They have to come in and manually program your number basically into the program for the door. It's battery operated, and it can be accessed either by a proximity card or a PIN number. These don't connect to LDAP at all, but they do make doors, by the way, that do connect to LDAP, that you have to authenticate some form or fashion with a personal authentication. It could be username, password, it could be thumbprint, it could be voice, it could be your walking gait, or a combination of all of those. And so one of the most recent, I think the latest Mission Impossible movie has a scene in there where Tom Cruise, he's having to walk through a hallway, right, about the width of this room, and in the hallway, he's having to act like he's somebody else, so they have to like swap out the card before it happens. But anyway, in this authentication, it's a palm print authentication before he enters the hallway. Then as he's going through the hallway, it tracks the gait of the user, and if those two don't sync correctly, the person can't get through the other door, and the door they just came through shuts until security gets there. And so there are businesses, by the way, in government that actually do that. You use a gate technology, and everybody has a certain gate. Now I know what you're thinking probably is, what if I get a bum leg or I stub my toe?
You just tripped coming in.
Yeah, well, evidently, I've never done this, but when they record your gait, they record it in a whole bunch of different ways to where even if you were to have an injury of some type, it can still tell it's you, if that makes sense. Kind of like when you do, like, if you guys done a thumbprint authenticate, you know how they have you like do the side of your finger and this side, you know, all different types, maybe a second digit versus just one. Same thing with the gate, they do the same fail safe, but that's not saying it couldn't fail, right? It could, like all these authentications could.
I don't know if it was for dramatic effect. The other day I was watching a duel between an FBI, you know, the duel between Apple and the FBI now, and they had one side representing one and the other. And then they had this woman who has a security company. I think she had sunglasses on for the TV, and they explained, the moderator said she has sunglasses on. She's not blind, but she doesn't want her irises read by
By the government,
or whatever.
by the Department of Justice, yeah. Well, I don't know if you heard in the news today talking about Apple. They did release back a response to the Department of Defense on this latest request using I think it's called the RIT Act, I believe, if I'm not mistaken. The RIT Act, is that right? Anyway, the precedents they were using for this RIT Act had nothing to do with authentication and nothing to do with encryption, nothing to do with anything that they were asking for access to. Anyway, the Apple lawyers went through a litany of wrong references that the Department of Defense was using. Then the IT person on the Apple side went through all the incorrect statements the FBI person made about the phone. He was talking about different settings and all this stuff, and he's like, I don't know if he was nice about it. He said, I don't know if you're in a different area, but the area you talk about in your report doesn't even exist. So he went through all this litany of stuff. So one of the commenters said, it's kind of funny that Apple has better lawyers than the Department of Defense. I don't know if it's funny or scary, but, you know, they made the Department of Defense lawyers look really stupid, basically, which isn't surprising. But anyway, I thought I'd share that because that had to do with what you mentioned about the Apple reference. So, but when you're coming to LDAP is very important when it comes to authentication. It's very important, and it's used. The reason open source is used on Windows is because years ago, probably in the late 90s, when Apple and Microsoft was still kind of separate before that and they weren't working together well, LDAP came on the scene to help bridge the gap of authentication and communication between Apple and Windows operating system. They have what's called an LDAP schema, and all a schema is different types of classes, like schema would be location, network ID could be in the schema, geographic location could be in the schema, a username has to follow a certain mnemonics, can be in a schema. So it's kind of like a rules-based rule for authenticating, if that makes sense. And so that's all a schema is. So here we have an example of a NOS, a network operating system directory, where users can access, a user account can be in there, a computer can be in there, a printer can be in there, a domain controller can be in there. But you'll notice the schema in this when they break it down to be object name, global unique identifier, required attributes, optional attributes, syntax, parent relationships. Then also needed in the schema, makes sense for authentication, username, user's full name, password, home directory. And then account information. Can they remote access? We just went over that a week ago. You know, is that available to this user? So schemas can change depending upon how it's set up by the network admin in LDAP. But the nice thing about LDAP is that it can be used across the board on different application types, not just network operating systems, but different applications and different types of objects. Now, the other term I mentioned on the slide is called OU. You'll see that term when it comes to network trees. OU stands for organizational unit. Here's an example of organizational unit. Microsoft, organizational unit. CBS, organizational unit. Rock Valley College, organizational unit. Whatever your company you work in, organizational unit, all right? So that's the top of the tree, is OU, is the top of the tree. Below that is subdivided in rectangles all the other objects in that organization. And generally, IT folks, when they're putting together a tree, they have to get with folks like HR, which has a little bit better feel for the organizational tree. Because have you guys ever seen an org chart at your workplace? You know what I'm talking about? Whereas like the CEO, right, and it's got the VP and the CIO and CFO and all these different titles. Right, all the way down to the different department managers underneath those boxes. Well, you're basically taking that top tier stuff anyway, and you're breaking it down though on how your business org chart is different than your company org chart for people that work there, right? So say you have at the top of your chart, your OU, which is the ABC company. Underneath that, the boxes, instead of CFO, CIO, all this stuff, the boxes would be departments. So you've got HR, you've got sales, you've got marketing, you've got research and development, customer service, whatever, right? You get the drift. All these are going across underneath the OU. Then underneath those boxes would be another box you could bring down in each one of them of groups of users. So in each group of users would be users, right? And then, so you have logically divided receptacles, and LDAP basically helps those trees be created. And the last bullet's important, which is root, branches, and leaves, like I talked about earlier, okay? Root, branches, and trees. You can add to a root, you can add to a branch, you can't add to a leaf, right? Leaves the last point that you can't add to. So let's look, we have a draft here, there you go, of what a OU or organizational chart looks like in networking. You've seen the ones at workplace, right? So here's how, a little different. The root would be the company name generally, okay, at the very top. Then the branches would be, generally, we'll just say for argument's sake here, an example's sake, the different divisions in your company, we could say. All right, so you could have in the containers, you could have HR, sales, marketing, R&D. Underneath those first level of containers, you could have other containers, and then finally in a container you could have a leaf. Like I mentioned earlier, would be like a printer, would be an example. So before you ever install your network operating system, before you ever do anything, you plan the tree. Kind of like we did in week 2 here when I had you guys plan the whiteboard on the different layout for, I think it was 12 computers, 3 rooms. Same deal, but you're doing it this time for a tree, for a network. So here's an example of Circuits Now, all right, company. You'll notice Circuits Now on the left side, this is how they exist now. They have printers, users, computers. It's a small company. It doesn't have, it's maybe just, 5 people in the shop or something, that's it. So there's no divisions, it's just, printers, users, companies is what they have, or computers what they have. Well, they want some future stuff to add. Say, we're going to get into some more stuff in the future. We only deal with circuit boards now, but we're going to get into chips in the future and transistors in the future. Those will become divisions in our company. There you go, of the new containers that could be created for future. So when you're creating a chart for companies, for your business, you also want to include in their future that could be 5 years down the road, 10 years down the road for your company with the dotted line type of layout. So in a one of these charts, you're also going to have shared applications as a container of different application types. And in those applications, you can have 3 different types of applications. You can buy an application as a user license only, seat license, or a site license, okay? So you're right now used to probably the per user one, right? So you bought at home, maybe whatever, give me a software you guys recently bought at home. Empty. Oh, give you a better one. When's the last time you bought an app on your phone? Give me the name of it. Android? AirDroid, thank you. AirDroid. Okay, did you have to pay for it?
Yeah, $3.
Okay, $3, there you go. So that was a per user license, he paid $3 for, okay? But take that example further, say he had 20 people working in his business, and let's just say for argument's sake that AirDroid, right, was available to companies to buy seat licenses as well. And what that means is you can have 10 concurrent seats out of your 30 employees can be on it at any time, meaning 10 people can use it at any time out of those 30. So, because the argument would be, well, not all 30 of them are going to use it all the time, so we only need like 10 at a time, maybe. We'll start out there. Does that make sense? Then the last one will be site license, meaning all 30 at any time, day or night, can access this application. Now, granted, the last one's generally more expensive than the middle one, and the middle one's more expensive than the first one, which is per user. That make sense?
What does Rock Valley use for Microsoft Office?
We have a site license.
Site license.
Your site license, yeah. Site license for Microsoft Office, and, you guys all know about the Office 365 stuff.
Yeah.
It's now offered to educational students and even faculty alike, for us anyway, no cost, which is awesome. Microsoft has always been good about that. But now let's talk about Adobe, okay, like Adobe CS, right, is on the cloud now. That one, very expensive, even for educational facilities. For students, though, I think, if I'm not mistaken, anybody have the CS cloud? Anybody have it? How much you pay a month for that? Is it 20, 15?
I paid
10?
the yearly fee, it's like 200.
How much is it?
200?
200 for the whole year. That's pretty good, actually, because I think monthly, if I'm not mistaken, the last time I checked, it was like $20, 15, $20.
Student
So you get a little break.
Student rate is $10.
$10 a month? Okay, not bad. And is that, what, 3 applications you can use, 4 applications?
It's all
2?
of them.
All the applications for $10. Awesome. So that would be, in that case, it's still a per user license, right? But like here on campus, to fill a lab, they had to do a site license for that, which was really expensive. And we had to get a grant for it and all that good stuff. And so that's an example of shared applications you could have on your network operating system. Now, installing applications on the server, it's a different type of application, number one, okay, because it's server related. It's designed to install on a server, okay, and for clients to access it outside the server. So one of the things that has to have in there, it's on the slide, is it has to have in there a way to verify, well, it does have the second one, verify that it's being used somehow, that site license is being used. Like an example I'll give you is, I was in graphic design for years, and we had a program called Quark Express that we used for our layout. It was a site, I take it back, it was a concurrent user license of 20 or 30. And so if you were number 21, right, it would pop up on your screen, you have exceeded your, seat license. Please wait for somebody to disconnect so you can connect to that application. And there was a small client on your computer that it would start the application, and then it would check it on the server for verification that you were in that range of 1 to 20, right? Then the rest of the application would actually be sucked down from the server and then run on that client, all right? So all updates would be done on the server. If you update your site license and add more seats or seat license, it would be updated on the server. And so that's something new you've probably not had to do, but there is site license or application types available for servers. And problem with shared file access is the fact that because multiple users can simultaneously access the data, you could have possible overwrites of data, if that makes sense, okay? What I mean by that is it's the statement we use in programming called last in or last out, last saved, basically. So if you and I are in a program and we're in the same area working on a report for some customer, and we'll say whatever program it is, we'll say it's, Access. We'll say it's Access we're using. If I make a change on something and I get out, but you're still in that same company record, that same customer record, and when you get out, your change is saved, which makes sense because you were the last one in there. And so one of the dangers of shared applications or shared files is what I just mentioned. You could have some overlapping. So a lot of times programmatically, companies will have to put some type of hooks in there to either lock the account or lock that file if somebody's in it. Like Microsoft will do this, by the way. Have you ever gotten a file that you got a pop-up that said, John Doe is currently using this file. Please wait till he's done. If you want to click a button to wait, It will send you a message when it's
We
done
have
and
that
released.
For tax forms. if
Yeah.
somebody's on a
Same deal, you can get that as well. You know, all Microsoft apps, by the way, or documents have that. So if I store a Word document on a network drive and I'm in it, working on it live on my computer, and then somebody else comes in and accesses that same Word document, it'll pop up that message and say, Chuck Conkle's working in this document. Do you want to be notified when he's done with it? You can click OK or yes, and it'll notify that person when they're done. Or you can, it does give you the option also to work on it as a read-only view, or third option you can actually access, which is, yeah, I want to make changes, but then when I'm done, if that file's available, it'll let me save it now to that file, or save it as a new file. So that's available as well. Shared printers. That's possible now with network operating system and shared resources on a network operating system server resource tree. So I can now set up a printer for all the departments to use separately. Each department can have their own printers. That's great for in network operating systems. So here's an example of 1, 2, 3 network printers connected to a network for all those clients to be able to print to. Really nice. And so gone are the days where you had to plug them in directly to a printer or to a computer and then set up the drivers on that computer. Now you can just connect to it via a server print queue and it'll install the drivers for you automatically on that computer if it's not already there, and set up the defaults for you automatically as well. Now, if you have older printers, by the way, and you might have had to do this in some of your workplaces, you maybe some old school printers or something, they're not network enabled. You can use old USB printers or new USB printers, share that, right click and share on that printer to the whole network so it can use it. A lot of companies might do that and still do that. I won't walk through how to create a new printer. You guys know how to do that, hopefully, or add a new printer to a computer. It's the same concept on networks. The difference is this: when you add network printers to a network operating system or network system, here's what it looks like a lot of times. We'll do RVC as an example. RVC, WTC printers. Okay, and then we'll do like HP 102 EE, HP 102 FF, whatever. And so what this is this is the name of the server, RVC. WTC is a folder in that server. Printers is a folder in that server. And then here's the actual printers themselves, the actual shared printers that people can connect to. And so a lot of times IT folks, network folks will know the path I just wrote up there and go to a printer or go to a computer that they're setting up new, the new employee or something. Just click on that link, the printer's link, and then click on the printer they're going to be using on that computer and add it as a default. Done. It'll actually prompt them, do you want to add this to your computer? Yes. Oh, I see you don't have the driver. Do you want to download the driver? Yes. And all that's on the server for it to be brought down and connected. Managing resources. Well, servers have a lot of resources, but they're still limited, right? Depending upon the memory, hard drive, processors, and granted, like we've got some really beefy servers here on campus, but they're still limited. But they can be accessed by multiple users, but there is, again, limits to maybe how many connected users can be on a certain device or a certain application, like we talked about. So because of that, you need to make sure when you're setting up your network operating system and all your applications that you got to talk about memory. I mean, we want the maximum amount of memory that we need, okay? And memory's pretty cheap, really. We want as many processors as possible, the fastest bus as possible, and hard drive space. We might need some extra hard drive storage, which they call SANS units today, SANS. And if we need to add more, we can look at that later down the road. And when you add more memory, more processing power, you have more speed and more, productivity to your people that are working on the network. Memory can be in two modes: virtual memory that can boost your total memory available, which comes from physical memory, which is the physical chips on the motherboard, and they can range everywhere from megabytes to gigabytes to terabytes, depending upon the chip that you buy. And virtual memory is stored by the operating system, and it's generally managed by the operating system today. You generally don't mess with virtual memory page files or paging files. You might have seen the root of your C drive. If you unhide all the files to view them, you'll see a huge file called a page file at the root of your C drive, which a lot of times grows pretty quick. It also might be in the root of your C System 32 or C System 64 folder as well. And all that is it helps a computer keep track of quickly accessible memory to be used at any time from any function, to where you're not having to physically think about, the computer's not having to think about where things are at or where things have been, where you've been, because it's in that page file. So a page file is kind of like a record of all the things if you can think of a book that you've read, and as you're reading a book, if you just picture that your computer remembers every click, every page, every software you've accessed, everything you've done, it keeps in that page file, along with the memory resources needed for that resource as well. That's all located in that page file, so you can get there immediately, quickly. So if you go into Word every day at 9 a.m., you fire up Word, it's right in the page file. Here's where Word's at. Here's what normal memory this person uses. That's going to be allocated, done. It's already in there. So it doesn't have to remember it each day. It's in the page file system. Memory advantages, virtual memory, is you can easily expand it, and the server generally does it by default. Disadvantage, if you manipulate virtual memory, you can really cause a lot of damage to you can degrade the experience that you're having on that network. You can slow things down. You can really mess things up if you manipulate and override the default, which is having Windows manage virtual memory and manage a page file. You can really screw up your experience. And what I mean by that is, when Windows manages virtual memory and a page file, it automatically does it as it sees it's needed, right? If it needs more memory, it adds it. If it doesn't need memory, it takes it away, but it does it in its own logic. An example would be if you have, say, 12 gigs of RAM at home on your computer, your Windows operating system will give you, say, let's say it gives you 16 gigs of virtual memory instead of the 12 that you actually have on the computer. And if you go in there and start messing with it and say, well, I'm going to bump it up to 20, because what it's going to use is above that physical memory of 12, it's going to begin using your hard drive space, okay? And when you start using your hard drive space, that's when it starts degrading the experience, if that makes sense. Because virtual memory uses not only physical memory, it uses the hard drive space to help with that virtual memory, if that makes sense. And so that's where the degradation comes in if you try to override it manually. And really, today's computers, you don't need to do that. Just let memory manage virtual memory and page file system. Multitasking is quick now because of network operating system speed and multiple processors and a multiple memory or expansive memory you can add to it. So some terminologies as it refers to not just servers, but just processes in your computer would be like the word process. That's basically just a routine instruction. Could be a program on your computer or network. Could be a service on your computer or network. A thread is something that's continually running all the time, either fast or slow or just waiting. And then processor systems is where basically one thread is handled at any time. And a thread would be like printer, send message to printer to check to see if there's anything in there. Network, am I connected? Am I connected network? That's what I'm talking about. That's constantly going on in the background in the processing system of a network. Networks also support multiple processors to handle or processes within that system, whereas your clients at home don't do that. Your our operating system does not support multiple processors, okay, as far as within the one system. And what I mean by that is you have, like say, you've heard the term quad 4 processor. Well, that's within one motherboard. I'm talking about having multiple motherboards within a server. Like here on campus, we have one of our servers have 32 motherboards on our servers that deal with our financial system and our data which is your online services. And so literally when you pop up the server, you'll learn to see the daisy chain of motherboards that are popped in that system. Client operating systems can't support that. Network operating systems can, because it's designed to do that. Same thing with hard drives. They have a capability on servers to do what's called RAID hard drives, a RAID 5, which is where you can do multiple hard drives on a network, on a server. If one fails, they can just pop it out and put a new one in, not ever have to restart the server or anything. It does it all live. They even have what's called RAID fans, meaning if a fan dies on a server, which a lot of times these servers might have 3 or 4, 6 or 8 fans on the back of the server, all right? And in the old days, we would have to shut the server down, take out the fan, replace the fan, restart the server, and be back in business. Well, today, with the hot swappable fans, we can now just unplug the fan. It'll actually alert us, fan number 4 is out. You go in there, just little clips, pull it out, put the new one in, fan starts working. So granted, during the time it fans down, the heat does rise a little bit, in that system, but it's not enough to where it can't still work. So you have to do it quickly. Sometimes a lot of these servers, if you don't replace it in such a time period, it will shut it down. But it does alert systems in there to alert people, and I think that's awesome. In fact, I met the guy from Apple, Keith Mountain is his name. When they had their server hardware, he created the RAID technology for fans that even Microsoft uses now, and Dell uses, and HP. The guy's like a genius. So I was in a meeting with him in Chicago, and he was explaining to us, the technology of this RAID fan on a PowerPoint slide, and he was going through all this. And, I was not going to ask a question. I was just listening, way over my head. About 5 minutes into it. But anyway, one of the guys that was in the meeting with me decided to ask a question, right? I was like, really? Because he asked a question like, something like, how much voltage does each one of these fans use that you created? It was like a kid in a candy store when he asked that question. This guy goes, you really want to know that? He flipped over another chart on a piece of paper, and for the next hour started describing in detail the voltage and how he created the voltage and how he calculated the voltage. And by the end of the hour, when we all walked out, I looked at that, I go, thanks for asking the question, because we were just like, he was like going to town about this voltage thing, and we're like totally lost. But this is the guy that created the RAID fan that has saved a lot of money for companies, a lot of downtime. So very cool technology. Multiprocessors, advantage on servers because of all the tasks happening all the time. So not only multiple, like say an example, I used to work at Sears going through college in sales, and we would log in on our little dummy client, a thin client. When we logged in, when I mean by dummy, we'd have a monitor, a keyboard, and a mouse, and a little box about that big. It looked like kind of like an Apple TV or a Roku box, right? It had no USB drives or CD-ROMs or anything. It just had a network cord plugged in, and at the back of the device had a keyboard plug-in, a monitor plug-in, a mouse plug-in. That was it. It's called a thin terminal. And so when you logged into it, the screen that you saw was actually being pushed from home office, right? That screen was being pushed from home office. I think it was down in Peoria, if I'm not mistaken, where they had the home office in Illinois. But every state of the union has a home office for Sears, that I found out, that they push some of these local retail units from. But then there's one that used just one of the locations does all the authentication for the entire organization of Sears. Can you imagine that? And so when I logged into my computer, I could just imagine all the other thousands and thousands and thousands and thousands of other employees that were connecting to that same server farm, basically, probably, connecting into this server to authenticate this network operating system. So you talk about multi-processing,
Pretty much the same time every day.
yeah, same time every day, break times, pretty much the same all across, but it's just crazy. But that's what servers allow you to do. And you just, as humans, we're like, it just works, right? But when it doesn't work, you're like, whoa, then you start realizing, all these other things are connected to one another. So here's a screenshot in the last slides I put together. This is actually the newest standards for Windows Server 2012 R2. Okay, revision 2. Just recently came out. These are the minimal requirements for Server 2012. It's called the Standard and Data Center Editions. So a 1.4 gigahertz 64-bit processor. And yeah, everything's going 64-bit, not just servers, but even clients. I mean, if you go to any computer store today, online or brick and mortar, you're going to be buying a 64-bit computer, okay? Within 5 years, 32-bit will no longer even be around in businesses. And what that means is, just so you know, there are a lot of softwares today that will not run in 64-bit. And I'm guessing even in the tax area probably. And they're going to be upgraded eventually because of the 64-bit, processor. So anyway, 64-bit processor, 1.4 gigahertz, 512 RAM, which is like super duper low. That is a minimal requirement, by the way. I'm talking you start it and it just screeches through, right? It just kind of along. So that's, minimal requirement. You say, what's generally normal on a server? In my estimation, on Windows Server 2012, probably about 32 gigs of RAM, roughly. That would be a low end too, kind of like a really nice number to start with, for a medium-sized business. 32 gigs available hard, definitely low end. I mean, that's memory basically. Most servers, you're talking close, in terabytes, basically, like 3 or 4 terabytes of data space generally available. A network adapter card, yeah, you got to have that. It's not going to work on the network. And most network operating systems will have 2 network cards, at least, but one you have to have. And a graphics card, at least supporting 800 by 600 resolution. Now, I will tell you on this one, that's generally the case. They generally don't mess with that adapter card too much because you don't spend a lot of money on an adapter card. On a server, why do you think that is?
You don't play games on the server.
Yeah. In fact, if you've ever been to a server and clicked on Internet Explorer, you ever got a chance to do that, you're like, why is it saying this is the first time you've ever accessed Internet Explorer? That's because it's the first time you've ever accessed Internet Explorer. It's not used to browse the web. It's used to just do server operations. And you know as well as I do, the more you're on the internet, the more you're susceptible to stuff that's on the internet, right? And so you're not really on there too much to do any, gaming or internet browsing. And so you really could care less about a graphical card because you're more than likely going to be remoting into it anyway most of the time and not in front of it. And so you really don't need a high-end graphics card. But that's the minimal 800 by 600, which yes, that's 80s, late 80s, early 90s is when that came out. Server management is done through one of the following ways. You can log in to the server's console, meaning it's sitting right in front of it. You can log in remotely, right? You can do that using Microsoft's remote desktop connection. Because it's Microsoft, they're not going to put in there or Team or VNC or all these other ones. They're going to use Microsoft, which it does work. And then by using the remote server administration tools on the workstation, there's a little plugin you can download on a workstation that gives you other tools or shortcuts that you can use to manage. The default installation option on a Windows Server 2012 is now the server core installation option instead of the server with a GUI, formerly called full, as in previous version of Windows Server. The reason for this are as follows. Server core requires less disk space than server with GUI, which can be important in data centers that use virtualization to consolidate multiple virtualized server workloads per physical host machine. So virtualized servers, or VMs is what they're called, are huge in this new version of Windows 2012 Server, right? It's used a lot. Server core has what's called a small attack surface. It's basically used for core cloud computing. Server core also has fewer software updates, meaning it's less service overhead. And administrators can switch between different installation options on 2012 without having to wipe and reinstall. So in addition to 2 installation options, a server core and server with GUI, you can now choose to deploy Windows Server 2012. There's a 3rd installation option now called Minimal Server Interface. This is a new installation configured after deployment by either a server manager or what's called a PowerShell. And so one of the big options with Windows 2000 Server 12 though is multiple virtual operating systems built in to servers, which up to that point, there really wasn't virtualization involved in Microsoft, but now there is embedded in the server OS. This last slide is talking about domains, which basically domains are consisted of a group of users, servers, and other resources. And here's an example of a domain. I already wrote up on our board. RVC could be a domain. Here's actually our domain name here on campus. It's RVCnet is what the domain is. So if I log in, if they say log in with your domain qualified username, it would be RVCnet and then my E number after that. And this would be the domain controller that is used to authenticate all users on campus, okay, even as students. Is when you log into any computer outside of this room, you go downstairs, RVCnet you might have seen possibly when you logged off of computers or logged onto a computer. The other I've already talked about, client-server architecture, and then Active Directory. There's tons of resources on Microsoft's website, by the way, on Active Directory. And I think it's week 12 or 13, I show you a little bit of Active Directory to play around with it, to show you how to get into it. One of the disclaimers I'll make, I guess, on Active Directory, if you ever want to play with it, is there is on your local computer, you can get into Active Directory on your local computer and set up basically rules for your local PC. And one of the things you have to be careful of is when you're setting up rules is you can lock yourself out. And I've done that before. And so one thing I always tell students, and I'll kind of walk you through on week 12 or 13 when we go through it, is make sure when you're testing stuff, like an example is, maybe you don't want your users to see control panel. I know when I taught high school computer class, I didn't want my students to see control panel because they always wanted to act printers, change default settings on a monitor, whatever. You know high school, remember, you used to be in high school. So I just wanted to get rid of control panel altogether. Well, in Active Directory, you can actually go in there on in the manager tool and uncheck to where the users, except for admins, cannot see control panel. Or maybe you want to see control panel, but you don't want them to see the ability to play with a display or add a printer. You can even go as far as, I don't want people to install software from any location on the computer, whether it be USB, drive, or downloads. Won't allow you to do it. You can do that also from Active Directory on the local.
Viruses and stuff on it.
Exactly. And these are kind of tips that a lot of people in networking or in IT don't use because it's totally free. It's built into every computer, even if you don't have a network operating system. Your local client has directory services, like I mentioned, to where you can go in and control this stuff. Now, granted, there are softwares you can buy that does what I just mentioned, but if if you get a good tutorial or you get a good resource that shows you how to do it, you can pretty much control a lot of stuff on your computers as far as accessing. But as you're doing it, what's cool about it is, or the danger is, you can lock yourself out. But what I found cool about it is, if you leave the screen open, you can toggle on and off and kind of see what it's going to look like before you close the screen. Because once you close the screen, it's saved. And then, your SOL, if you come back and you say you check mark the setting of don't let anybody log into your computer, but this user, maybe that user you typed in doesn't even exist. Well, that's not good. because you can't get in that computer again, even if you're an admin. And so the way network admins use the Active Directory is they'll sit in front of a computer like yours, and they'll go through all these rules, right, of what they want the clients to have access to and don't have access to. And then they can save that file as it is. It lets you save it. Then you can take that same file and bring it to the network operating system side and import it and apply those same rules to every user in a group, which is awesome. And that's what Active Directory allows you to do, which is very powerful. But a lot of network shops don't use it because I think it's because it's so powerful and because of the dangers I just mentioned. You wouldn't want just anybody and your brother going in there and doing stuff. And so, but it is pretty powerful. Microsoft really doesn't push Active Directory too much as far as really people learning it, I think, as they should. But because you can do a lot of neat stuff. The other thing that a lot of people don't know about, I know we have some parents in here, is Microsoft has built into it, in the new OSs anyway, even for the clients, really good parental controls. Does anybody use them, by the way, for at home? They have really good parental controls on Windows clients now for parents to lock down pretty much everything, or you can see, you can give your kids certain time frames to work on things, or internet time, game time, social media time. And you're like, well, it doesn't really matter because they have a phone anyway. So, but you can control that too, right? If you like, AT&T has a parental panel with that. You say, well, they can get around that too. Yeah, I know. But then you have the last resort as a parent, which I used to do, is you take the phone to bed with you when you go to bed. All right. So that's it for this discussion tonight on network operating systems. You have your take home. If you have a question about that or anything else, let me see me before you leave. Next Thursday, we're using that night for study night, so no class next Thursday. In that discussion for week 10, the week 10 lab, there is a PowerPoint to watch or a slideshow for you guys to watch that helps you on getting started with your outline. I have you watch that and kind of tell me what you got done, basically, is all you have to do for next week's lab. Say, okay, I finished up my research paper outline and started researching point 1 or something like that. Okay, but there is a little slideshow I have you watch, a little Prezi slideshow on how to create an outline. You also do have an example in there of a PowerPoint template that you can use if you want to. You don't have to, because you can use PowerPoint on your presentation. You can also use Prezi. I've had students use a whiteboard, use video. It's a whole plethora of things you can use. But before you do the presentation, I recommend getting your research paper done first. All right? So that's all I've got. Everybody have a great week, and I'll see you in 2 weeks.